Hey, Java students. I am here with you today because I figured as we get into this next unit, some of it's going to be review, but it's been quite a while since we wrote classes together. So I figured I would walk you through the lessons. I don't know if you have the capability to watch this video or listen to it at the same time as trying to do the work, but get yourself set up. For this lesson, you're going to be in CodeHS. Again, we are Unit 9, and I'm looking at Lesson 1, and I'm assuming at this point that you have already watched the video at the beginning of Lesson 9.1, and you have taken the little quiz on subclasses and superclasses. So I'm going to pick up with the exercises and examples and just talk through them with you on starting at 9.1.3. This may not be the most efficient lesson ever because I'm just going to talk through it at the pace that I would think through it myself, but I hope it's informative and helpful to you to get it done. And I will be looking for you to have these lessons completed in your own account anyway, even though I'm going to kind of tell you what to do and show you the exact solutions as we go. So, all right, let's do this. Okay, first, this 9.1.3 person superclass is just an example. For this lesson, we are encouraged to play around with it, run, change the code, learn how it works, and then continue on to the next problem. So what I'm going to do is basically look at, first of all, the tester, which sometimes we call the runner class or the client class. It's got the main method in it, and it is declaring two different objects. The first one, it's declaring with a reference to an object of type person. So this is our reference variable to point to an object of type person. Then we actually create an object of type person with the new keyword, and we send in as parameters to the constructor the name and the birthday. So person class must have a constructor that takes two parameters. Then we actually create a second person named my student. This one is being created with a reference variable to point to an object of type student. And then we create a new student and we send in three different parameters. Oh, sorry, four: the name, the birthday, the grade, and the GPA. So let's take a look at these two classes. Person is the superclass. It's the one that actually has fewer instance variables, but then student will inherit those and add more to it because it's a more specific kind of person. So even though a superclass has fewer instance variables, it's still called the superclass. It's smaller in the number of instance variables, but it's above the others. Okay. So person has a constructor that takes name and birthday, and those are the only two things that a person has. And then we've got the getters, and we've got a toString method that allows us to print it out neatly with the name and the birthday both on one line of code. All right, the student class extends person. It adds two more private instance variables, grade and GPA. Now notice it's not shown here, but you could kind of imagine the instance variables of the person class are here available to us. And in fact, if we create a student object, we should be aware that the name and birthday instance variables or attributes should also be taken into account and set by the constructor. So here we have the student constructor. It takes four different parameters. And notice that it calls the superclass constructor, sending in the name and birthday to start off initializing the instance variables of the person type. Then it goes a little extra and initializes this object's grade to be the grade and this object's GPA to be the GPA that's passed as a parameter. I really don't like using the same variables for parameters as the variable of an attribute, but if you specify with the this keyword, it does work and it's valid. Okay. Typically, I like to give them different names so that there's no confusion, but Okay, so then we have a get grade and get GPA. We do not have a toString method for the student class. So if we were to try to use a toString method on a student object, it would end up doing only the name and the birthday. All right, going back to the person tester client class, I'm just going to run it and see that it creates the two objects. It prints out the my student.name Emma, my student.getGrade 11, and then with the person, we can do get name. We could do get birthday, or we could do system.out.println. Yeah, let's do birthday. And then we'll have Tyler and his birthday. You could experiment here in the client class trying to call different things. Like, what if on the person we try to call grade, get grade on Tyler. So if I try to invoke my person.get grade on an object that's not a student specifically, we should get an error. Yeah, see, variable my person, the method get grade is not found for that kind of object. It would only be found for a person, a student object. So all the methods of the superclass are available to the subclass, but not the other way around. That's just something we should probably play with and get used to there. Okay, I'm going to take that out and run it again and just leave it in a good state and continue. All right, this is an interesting example. It's got a test class that just invokes the various objects and then prints out the various attributes of them. The objects we have, and you can imagine this in your mind, we've got vehicle, car, and bike. So vehicle is the superclass because both bike and car are types of vehicles. So what does a vehicle have as attributes? It has name, engine, and wheels. So the name of the vehicle, the type of engine, does it have an engine or not? True or false, Boolean, and how many wheels. So if you just create a generic vehicle, you can set all three of those things and get all three of those things. Set them with the constructor, get them with the getter methods. Now, if you look at the bike class, remember, since it extends vehicle, it will inherit the private instance variables from vehicle. So then it will add two additional attributes, color and type. When you create a bike, the constructor will take the color and the type, and it will call upon the superclass constructor. This super line here is calling upon the constructor from the superclass to create an object of type vehicle that is bicycle. It has no engine and it has two wheels. And then it's going to further set the specific attributes for bike. This color gets color from the parameter, and this dot type gets type from the parameter. And then it adds additional getter methods for those specific attributes. Notice it does not necessarily have to redefine the get engine type and the other attributes from vehicle. Those methods are inherited as well by the bike object. But it does create a toString method specifically for bike. And it will say a red mountain bike, let's say. Sorry about that. Was my dog. He wants to get closer to me while I'm working. Okay. So we have the vehicle, and as another subclass of vehicle, we have car. Car will inherit the attributes of name, engine, and wheels from vehicle, but it also defines two additional attributes, make and model. When we have a constructor for a car, we're going to take two parameters for the specific attributes for this class, make and model, and we're going to call the constructor for the superclass so that we actually create a vehicle type that is a car for name, true for whether it has an engine or not, and for number of wheels. Then we have to set the attributes that are specific to this class using this.make gets the parameter make, and this.model, this object's model attribute takes on the value of the parameter model. And then we have definitions of getters for the new attributes of a car. Car extends from vehicle. It also inherits the methods get name and has engine and get wheels from vehicle, but it also it overrides and overloads the toString method so that it's specific to a car. So if you call toString on a car type, you will get and then the make and a space and the model. Okay. If you run this code looking at the vehicle tester, we expect it to create a car called reference variable is Tesla for that. And a bike, reference variable Trek. And we are using the specific constructors for the car and the bike, but we are getting the values set by the superclass constructor because of that super line at the beginning of the constructor of each of them. This line, super, means that those vehicle attributes are going to be set also. System.out.println Tesla prints out a Tesla Model 3, just the make and model. Then to print out the other values, we're kind of invoking specifically the get methods from the vehicle class here on these two lines. Then we have printing out the Trek. If we do just a system.println on a Trek, it's going to invoke the toString method for an object of type bike, which will only give us the color and the type of bike. If we want to see the engine and the number of wheels, like the status of whether it has an engine or not and the number of wheels, we need to actually call those methods from the vehicle class. And they are accessible to the subclasses, but they just haven't been included in the toString method for bike and car. So that's why they're not showing up unless they're specifically called out in these lines. Okay, let's continue. I think I need to go back to the original version of this one. I don't think yours will look the same as mine here. If I reset the code. Okay, the original code has a person type with name and birthday again. It has a student type and a high school student type. This is a 3-level hierarchy, and it says that we are, again, looking at an example. We're just encouraged to look at it, play with it, run, possibly change the code if we want, and then move on to the next problem. So I'm just going to talk through this one. We have a person class, which is name and birthday, and a basic constructor, which is those two attributes, and get methods for both of them, accessor methods, and a toString. Student extends person. So student inherits name and birthday, but it also provides attributes for grade and GPA. Grade being like grade level, 11, 12, 9, 10, 11, 12. It calls the superclass constructor to create the object, and then it specifically fills in the other two attributes with parameters from the constructor of this object. It provides accessor methods, the getters for grade and GPA. It does not create a specific toString method for person. I'm sorry, for student. This is the student class. There's no specific toString method defined. Now let's look at high school student. High school student actually extends from student. So it inherits the attributes of student, grade and GPA, and it also inherits from the grandparent of that name and birthday. So a high school student has name, birthday, grade, GPA, and something additional, service hours. Calling the superclass constructor here, we're going to send name, birthday, grade, and GPA. And that's going to invoke the student constructor that takes name, birthday, grade, and GPA, which in turn is going to invoke the person constructor that takes only name and birthday. So there's this kind of cascading method calls going on behind the scenes. Then we still need to set the number of service hours after constructing the high school student object using the superclass constructors. We still set the service hours to whatever we are passing into this constructor. And we have to provide a getter method for that as well. So looking at the person tester, here we have first a person object being created with just a name and a birthday. That's really all you can give to a person object. The reference variable is of type person, and we have created an object of type person to assign to that reference variable. Remember, the reference variable just holds the address of the memory location where this object has been created. Then we create a high school student reference object called myStudent reference variable. And then we have the actual object, high school student. And we are sending in all the information for Emma, name, birthday, grade, GPA, and service hours. When we go to print out myStudent.getName, my student is a high school student. So this is going to get the name, use getName from actually the person object, because it inherits that method. It has the ability to use that method. From the student class, myStudent.getGrade, getGrade is specific to student, not person, and it's going to use that method. And you can also print out myStudent.getServiceHours because this is a specifically high school student. It says with the person class, we only have access to methods from the person class. So if we try to do anything with myPerson, it can only be specifically things that are defined in the person class, not the subclasses. So we could get his name and get his birthday and do a toString. That's it. Run the code, just see what it does. If you want to stop the video and play around with it, try what would work and what wouldn't work, see if you get errors. That's always a good idea. Okay, I'm going to move on to level 6, 9.1.6, person student object. Okay, this one's an assignment. It says in this exercise, you're going to use the person and student classes to create two objects. Then print out all of the available information from each object. Okay, now mine looks like yours. If you look at the runner method, the runner class with the main method, it just says start here. And we already have the student and person classes defined. It says we do not need to modify the student or person classes. We are just going to create objects in the runner class and invoke the methods that are available to print out specifically this information. So notice that person is the superclass, student is the subclass. Person has name and birthday attributes and a get birthday and a get name method. Student adds two additional attributes, grade and GPA, and also methods to retrieve those values, get grade and get GPA. So in the person runner class, if the first thing I want to do is create a person object, I'm just following what they say here, create a person object with the following information. I'm going to need a reference variable to point to an object of type person, and I'm just going to call it Tom. And I want to create a new person object. And I'm going to send in the name Thomas Edison, because that's the first parameter of the constructor for a person object. And I'm going to send in the birthday, February 11th, 1847. The second parameter for the constructor for a person object. Then I want to create a student object with the following information. I'm going to call it Al. I want to get a reference variable called Al. And now I'm going to create the actual object, a new student. And his name is going to be Albert Einstein. And his second parameter is going to be birthday, March 14th. Pi Day. Is that for real? Albert Einstein's birthday was Pi Day? I did not know that. Okay, and his grade is 12, so I'm just going to send that as the next parameter, and GPA is 5.0. Now, I'm actually not sure. I didn't look carefully at which the order of the parameters are for a student. Okay, it is grade and then GPA. All right, looking good. So there's my two objects created, and now we want to print out the information for each of them. So if I go to print out a person object, I don't have a toString method. So I will have to just print out the name and birthday separately with different system.out.println commands. And I'm going to put prompts, little labels in front, like name, exactly the way they show here. Name and then a space, and then my person objects tom.getName. Then close the parenthesis for the print line command. And next, I'm going to do system.out.println birthday. Going to try to make it look exactly like the output that they have there with a space afterwards, and then tom.getBirthday. So I'm invoking the class method on the object of type person. Okay, next I'm going to print out the student object. Now in student, they also did not include a toString method, so I'm going to have to do each of these things separately. I'm going to actually copy paste my first two lines of code here and just change it to Al, because why type everything out again? Just change it to al.getName, al.getBirthday. Now, I know that Al is a student type, but the student inherits the methods from the person, so it can access the getName and getBirthday methods. Now I'm going to include system.out.println grade, and then al.grade, and system.out.println GPA, space, quote, plus al.gpa. Oh, it's got to be get GPA. We are invoking the student method get GPA, and that's how it is. Capital GPA is lowercase. All right, I'm going to try to run my code and see if it looks like the example. Oh, I have a typo. Print line, turn to, okay. Run it again. Oh, I forgot the get grade. I just decided to try to access the private instance variable directly, and you cannot do that. That's why it's private. Okay, so I've got name, Thomas Edison, birthday, Albert Einstein, birthday. Looks good to me. Now let's see if when I check it, they agree that I did it correctly. All right, all looks good. I'm ready to move on. You may still have some typos. If you need to, stop the video here, catch up, and then continue. Okay, I am on now 9.1.7, books. And I'm going to read the assignment. For this activity, you're going to refactor the book superclass and the dictionary and fiction subclasses. Right now, the book class is empty, and the dictionary and fiction classes have instance variables and getter and setter methods. Your task is to move common attributes and methods to the book superclass and remove them from the subclasses. Note, you do not need a constructor in any class. Okay, so all we're going to do is what they call refactor this. Book would be the superclass because both fiction books and dictionary books are considered books. But let's look at the attributes that they have. A dictionary has pages, name, and number of words. A fiction book has pages, name, and author. Okay, that's interesting. So pages and name are common to both fiction books and dictionaries. So those are the attributes we're going to remove from the book class. Remove from fiction and dictionary and put them into book. We're going to take out pages and name because dictionary has pages and name. Fiction also has pages and name. And what we want to do is make the book class kind of consolidate it so that those shared attributes are in the superclass. Okay. Now, if we're going to take those attributes out of the dictionary and fiction classes, we should also take the get name and get pages and set name and set pages out of the subclass definitions and put them up at the top in the superclass. So get pages, get name, set name, all of that is coming out. I'm just going to Control X, cut, and go to book, paste, Control V. That I took out of dictionary. So the only thing specific to the dictionary type is how many words it has. Everything else will be inherited from book because it extends book. Fiction, I can also get rid of the get pages and get name and set name. Here I can just delete it because it's already in book. And so now when I go to the book tester, I should be able to run it. And hopefully it still works. Here we go. All right, so it just printed out the name of Hunger Games and the name of Webster's dictionary. That's really all it was supposed to do. If we want to see more, we could print more using the get pages and the various attributes for fiction and dictionary. But right now, I think I'm just going to run check code, and I believe that I have satisfied the assignment. Waiting for the test cases to be run. Taking a little longer than I expected. Okay, finally got it. I didn't change anything. It just finally came out correct. So I'll be moving on to the next exercise. Okay, for this exercise, we are going to design 3 classes. The ultimate superclass is going to be the computer, and then it will have 2 subclasses, laptop and desktop. I don't believe this is like the high school student, where the high school student is at the bottom of a 3-level hierarchy. This is just one superclass that has 2 different subclasses. You will design these classes to optimize the superclass-subclass relationship by creating instance variables and getter-setter methods. Include the following instance variables: screen size, inches of monitor space. I believe both laptops and desktops would have that. Memory, gigabytes of RAM. That would be for both. Battery life would be for only the laptop. And monitor is whether or not a monitor is included. I believe that would go to just the desktop. Each class should have at least one variable in it. So once completed, the tester class should execute without error. All right, we have the tester class. It's going to create a laptop called a MacBook reference variable. It's going to set the battery life to 8.5. Then we're going to create a desktop with a reference variable named Dell and set the screen size to 18. Then the Surface computer, interesting. Surface is going to be a computer type, and set its screen size to 11. Isn't a Surface kind of like a combination? Is it a laptop? Is it a desktop? I think it's a laptop, but it's like a tablet. Anyway, then we're going to print out the battery life and screen size of each of them. So let's check out the highest level computer class. Right now it has nothing defined. So in the assignment, we're going to put instance variables that are common to both laptops and desktops. We're going to put them at the top under computer. So that would be screen size, actually memory. Memory is definitely common to both, and it's a private instance variable. Battery life is only for laptops. I'm going to say screen size should be for both. Okay, yeah, I do believe that screen size is going to come into play for both, because you really can't use a computer that doesn't have a screen. So I'm going to add that here, private attribute int screen size. And it says in the assignment, create the instance variables and the getter setter methods. So for each of these instance variables, I'm going to do a public get method. And it has to return the same type as the attribute. So return screen size. Then a public method to return the memory. Get memory. We'll just return memory. And we want to have a setter method for each of them. I'm going to put that actually up here. Public void. It doesn't actually return anything, it just sets the value. So that would be set screen size. And we'd have to have a parameter coming in for that. We'll call it the size. I like to use a different variable than the name of the attribute, just so that it's clear what's going on. The attribute screen size is going to take on the value of the parameter, the size, that is sent in. And public void set memory int GBs, gigabytes, and we'll say memory gets GBs. Okay. So this is the superclass phase. Now under laptop, we want to make sure that it extends computer, so it inherits screen size and memory, but a laptop will specifically have a private instance variable of type double called battery life. And we want to do a getter method for that and a setter method for that. So we'll start with the setter method. Public void set battery life to a double type life. We're going to say battery life, that's life, the parameter value. And we will also do a public method to return or get battery life, no parameter, but it returns a double, it returns battery life. Okay, and we're going to do the same thing for desktop, and it's going to extend from computer, inherit the screen size and the memory, but it's going to have a Boolean, a private Boolean type attribute called monitor, which will either be true or false, determining whether the computer comes with a monitor or not. So we're going to do a public void set monitor, given a Boolean value called comes with, I'll make it included. I don't like that word. Make it has monitor. Good one. And then I will just say monitor gets the value of has monitor. And finally, we're going to make a public method that returns a Boolean value called getMonitor. And it has no parameters. It just returns the value of monitor. So we've got all of these variables defined somewhere, whether it be in the superclass or the subclasses. And if we look back at the computer tester, we should be able to run it. So here we go. Let's see if we made any mistakes. Uh-oh, I did. I missed a bracket. Public class desktop extends computer. I see. Desktop extends. It's supposed to be with an S. Okay, let's try again. Let's see. Cannot find symbol get battery life for a MacBook. So let's see. Under laptop. Oh, get battery life. I used a lowercase b when it should have been an uppercase b. All right. Let's try again. And now I've got it printing the battery life, the screen size for the various computers. Now I will check code, see if all of my test cases work. They're not my test cases, they're CodeHS's pre-designed test cases. Waiting. Okay, I have verification that what we did should have worked. And at this point, I'm going to say I've gone through all these activities with you except for the last one. And that one I leave for you to try on your own. And I'll be just checking that you have this lesson completed in CodeHS. Hope this has been helpful to you. If you listen to it, then you just have the one exercise to do on your own. But please do go back and fill in these on your own account as well, the ones that I've shown you what to do. Get them to work. And if you have any trouble, as you know, you can always email me or do the Google Hangout chats. And if I don't hear from you, I will assume everything's okay. And I hope I see you guys sometime soon before the end of the school year. Be well and take care. Bye-bye.